Welcome back. Today we are going to be looking at lesson 2-2, which is our first real geometry lesson, and it is going to be on points, lines, and planes. So I am going to share my doc camera here so you can see my notebook. There we go. And so this is lesson 2-2, points, lines, and planes. So there is a lot of vocabulary in this section. As you're going to find in geometry, we have tons and tons of vocabulary. So you are going to need a highlighter so that you can highlight all of your vocabulary terms. And so we're going to first start out with a vocabulary term. So points, lines, and planes are all called undefined terms. Well, what is an undefined term? How do you define something that can't be defined? Because it's undefined, right? So these are simply things with no definition. Hence their undefined definition. They are defined by drawing a picture. So that's the only way you can define these. So in your guided notes, you should have this paper. You probably only have, let's see, you probably, if you have two of them, you're going to cut it in half and give a piece to your neighbor. Let me grab a pair of scissors really fast. Okay, so I'm going to cut this out. And then I'm going to go ahead and cut around the outside so that I only have the table. And I'm going to go ahead and I'm going to wait to tape this in just so it'll be a little easier to write. Okay, so we are going to look at undefined terms are points, lines, and planes. Those are the three undefined terms. So we can't really write a definition because they can't be defined. They can only be defined through pictures. So a point, let's see, a model for a point is going to be like a Google Map point. So it can be drawn with a dot. These are always going to be named. So they're going to be named with a capital letter. So they are named by an uppercase letter. Facts about them, they have no dimension. They don't have any length, they don't have any width, anything like that, no dimension. They are simply a location. And then the last one is words or symbols. So that means, how am I going to say this? Well, I'm going to say this as point A. I can't just say A because we're going to learn that there are a whole bunch of different different things that get named, and just saying A could be a lot of different things. Okay, so let's talk about a line. A model of a line. So something that's real life might be the edge of a table. What you're going to find is there are two different types of geometry. There is theoretical geometry, and then there's like real life geometry. So what we're going to find is that theoretically, some of these don't, I mean, theoretically, might be a little bit different. So the edge of a table is going to have ends. It's going to have stopping places, but a line itself does not. So a line is going to go on forever and ever and ever. You have to have 2 points on a line to define it. So it has to have at least 2 points. It may also have a script letter naming it as well. So named by, it is named by any 2 points on the line It can also be named by a lowercase script letter. So some things about it. Facts. It is never ending in both directions. And lines are one dimensional. They only have one dimension, and that would be length. So how can we say this? So we can name this as line L. So we can name it with the lowercase script letter. We could also say line AB. So we can use any 2 points on that line. We can also write this symbolically like this. And this means line AB. One of the really cool things I love about geometry is that you can use what's called technical writing in geometry, and technical writing allows you to abbreviate things. So we have abbreviations like this, and this we say this as line AB. Okay, so the next one is a plane. So a tabletop might be an example of a plane. And again, it is not, it is finite. So it has stopping points. Remember that theoretical geometry does not. So we are going to draw a plane like this, but again, this appears to have edges. Planes do not. They go in th 2 dimensions, never ending. So again, theoretical versus realistic. So we can have a name, which is a uppercase script letter, or it takes any 3 points that are not on a line. Pin's not working very well. To name it. So it is named by an uppercase script letter. So that would be the B, so it would be plain B, or 3 points that are not on the same line. So they just can't be in a row. Some facts about it is 2 dimensional. So it has length and width. And it is never ending in 2 directions. And let's see, we can name this, like I said, either by the uppercase script letter. So we would say plain B. So again, this is why I told you that you can't just say A here, because are we talking about okay, script A? Or are we talking about plain A? Or are we talking about point A? So we always have to say this word ahead. So plain B. We also could name this by any three so not points that are not on the same line. So we could also call this plane ABC as well. Okay, so there are your first 4 geometry terms, vocabulary terms. So go ahead and you can tape that in there now. Remember our tape rule, 1 inch or less is all you need. Okay, there is one additional undefined term that is not on this nifty little diagram, and that is space. So I'm going to highlight that. That is also a vocabulary term. And the definition, so space, again, I'm going to draw it like a cube, but think about if you were in your bedroom, that is your space. So space has 3 dimensions. So it's 3 dimensional. Technically, space is in all directions infinitely. So technically, it doesn't have a stopping place. So it is never ending in three directions. It has length, width, and depth. Okay, so those are our first ones. We're going to continue on and keep going. Again, we have more vocabulary terms to add in here. Our first vocabulary term for this page is collinear. Now, you can look at this word, and collinear has the word line in the middle, right? And co means together or with. So collinear. Collinear simply means points on the same line. So, for example, if we have a line and we have point A, point B, point C, and point D, we can say that points A, points B, point C, and point D are all collinear. Okay, our next one is coplanar. I bet you can guess what that means. Coplanar is, yep, you guessed it, points on the same plane. The only kicker to that is if they are on the same plane, um, they have to be non-collinear. So in other words, they cannot be in a line. So if we have a plane, let's say we have plane A, then points A, B, and C are known as collinear, or I'm sorry, coplanar points. So non-collinear, again, is also a vocabulary term. And the non is just pretty much tells you what you need to know. They are points not on the same line. Just use a little negation there, not on the same line. So let's say here's our line and we have points A and B, but point C is down here. So point C is non-collinear to points A and B. And you guessed it, the other one is non-coplanar. This would be points not on the same plane. So if our plane is here, remember we had plane A, and we had points A and B on plane A, and let's say point C is not on the plane. So it is a non-collinear point to the others. We also have skew lines. Another one that doesn't like to write. And a bunch of duds today. Oh my goodness. Yeah, really. What's going on with all my pins? Skew lines. Okay. There we go. Skew lines. Skew lines are any two lines. This really can be more than two, but any lines that are non-coplanar and not parallel. So, when I think of skew lines, I think of when you have two airplanes and you've got one airplane going this way and you've got another airplane going this way, they are not on the same plane because they're not going to hit each other. But they're also not parallel because if they're parallel, they'd have to be like this. So these are two lines that are non-coplanar and non-parallel. I'm going to put on here, think airplane travel. So in other words, let's say you have a coplanar line, but then you have a line up here that's going this direction and it's not on the same plane. So not on the same plane, not going to intersect. Another way we could do it is if you run it through the line like this, these are not intersecting because it goes through the line here and this line is on the plane. So a little bit different there. Some things that you need to know are that through any 2 points, there is only one line. So through any 2 points, there's only one line. So you won't get multiple lines out of 2 points. And through any three non-collinear points, there's only one plane. So a couple of things that you need to know there. All right, so the first thing that we're going to do is we're going to look at our examples. So in your guided notes, we need this side. So if you'll cut that out, hopefully this is going to fit on this page. Put a little bit off the top and the bottom of mine just to make sure it's going to fit here. Okay. And again, using my tape rule, we're going to put those in. Okay, so the first one says, give two other names for a line containing point Q. So point Q is right here. So some ways that we could name this, of course, we can name it with the lowercase script. So we could say line C. We can also name it with different points. So if we know that this is a line containing point Q, we could say that this is line RT. We could say that it is line QT. Lots of different ways that we could name that line. So the next one says name a plane containing point S and point T. So point S and point T is this plane. We know that this plane has a script A, so we could say plane A. We could also use any three non-collinear points, right? So we can't use T, R, and Q because that would not be a plane, that would be a line. But we can use plane STR. We could also say STQ. We could also say QSR. There's no, doesn't have to be in any specific order. Okay, so we're going to use this guy down here for 3. So how many planes appear in the bottom figure? So I see this plane right here. We've got this one, this one, this one, and then you've got your 2 in the back that you can't see. So this is not its own plane. This is sitting on plane P. So we have 1, 2, 3, 4, 5, 6 planes in the figure. And then the next one says name a point that is not on plane P. So the only point not on plane P, so J is not on plane P. Notice that this is dotted right here. That means that it intersects and goes through. It looks like B and A are not on the plane, and these are all sitting on the plane. So those are on the plane, even though they're also in the figure here. So we could say point J. You could have said point A. You could have also said point B. All of those are going to be not on a plane. Okay, so the next part says sketch a plane and a line that is in that plane. So we just sketch planes with a a parallelogram like that. We are always going to name it. So I'm going to name this one, no, let's name it D, plane D. And I'm going to sketch a plane and a line that is in that plane. So I'm going to put a line on my plane. And again, I have to make it so I can at least name it. So line AB is in plane D. The next one says, sketch a plane and a line that do not intersect. So if I have my plane here, we're going to make this one plane E. A line that does not intersect. So remember that these go on infinitely. So putting one over here is not going to work because technically this keeps going this way and they would intersect. So the only way this is going to happen is if you have a line up here that is actually parallel to the plane. So we're just going to give this some letters so that we know. And so those are not going to intersect. We know they're not going to intersect because they are parallel. So we're going to put little parallel markers on there so we know that they're parallel so that they will never intersect. Okay. So some more vocabulary. We have defined terms. So we learned about undefined terms. Now we're going to learn about defined terms. These are ones we can define. But these are ones we can define, but you have to use the undefined terms to do it. So these can only be defined by using undefined terms. That's undefined terms. So the first defined term that we're going to learn is a line segment. And again, this is vocabulary. So I'm going to highlight that word so I know that I need to know it. It is part of a line with endpoints So part of a line with endpoints. Endpoints is actually also a vocabulary term. A line segment is always named by the endpoints. So, for example, if I have part of a line that has endpoints, we can call this segment AB. We could also name this segment BA. They're both exactly the same thing. You can say it either way. And we would say, oops, segment AB. So that is a line segment. Our next vocabulary term is a ray. Um, a ray is a part of a line with one endpoint. Some people call these arrows. The endpoint is always named first. So let's say we have this figure, part of a line, right? With only one endpoint, which means the other side. So we are going to call this ray CD. Notice that the C is going to be in front because the C is the endpoint. The endpoint is always named first. We would say ray CD. Okay, next one is opposite rays. And again, another vocabulary term. Opposite rays are two rays that have the same endpoint. but go in opposite directions. A lot of people notice that, yes, opposite rays will create a line. So let's say this is D, that one's F, that point is E. We can say that ray DE and ray DF are opposite rays. Notice that the D is both the endpoints are always first. Okay, our next vocabulary term is intersection. So just like an intersection that you drive through, this is very similar. This is where two lines or more, can be more than two, meet. So there can be an intersection of two lines or more. When that happens, they will always meet at a point. You can also have an intersection of a plane and a line. Here's my plane. You have a line that's going to go through it. It's going to stop, and then we're going to do this. So these dotted lines are just like showing you that it's behind. This one is also going to intersect at a point. And then the last one is the tricky one to draw. So this one is of two planes. So we're essentially going to have a plane that goes this way, and then we're going to have another plane that goes this way. This, of course, is behind, so you don't see it. That should be the intersection, sorry. So this is kind of hard to see, but this is the front plane here. And the other one is back there. So these intersect in a line. Okay, so you can take your other part of your guided notes. So we are going to give a name for the segment lying on line P. So here's line P. So we're naming a segment. So we only have C and D on there, so it has to be segment CD. Could also be segment DC. Name all of the rays with endpoint A. So there's only one ray with the endpoint A because we don't have any way to name that one that's going that way. So we're going to say ray AB. Remember, A is going to be the endpoint, so it's got to go that direction. Name two sets of opposite rays. We're going to skip that one because we don't have any opposite rays at all on there that we can name anyway. And let's see. Next one, name the intersection of line PQ and line K. So here's line K, here's line PQ. The intersection looks like it is at point M. Name the intersection of plane A and plane B. So here's your plane B, here's your plane A. The intersection would be at line K. Name the intersection of line K and plane A. Well, line K is on plane A, so there is no intersection point because it lies on it. So lies on plane A, so it intersects the whole, so line K is actually the intersection point because it lies on it. So we're going to sketch a line and a plane that intersect at a point. So we're going to start with our plane. We're going to give our plane a name. Let's call this one K today. And we're going to sketch a line and a plane that intersect in a point. So we're going to make a line that goes off of this and goes back behind it. We can't see it. And it goes there. And then we're going to name saying that's point A. Sketch two planes that intersect. So this is the one that you guys are, it looks like this. It's kind of tricky. So we're going to draw this guy first. And then I'm going to make this one go this direction. You can't see that part. And the intersection point is going to be at a line. So if you want to color one of them, just to make it a little easier to see, you can do that. All right. The only last thing we need to put on here are parallel lines and perpendicular lines, parallel lines and parallel planes. So parallel lines are two lines that will never intersect. But we can't just leave it at that because that would also be the definition of intersect. That would also be the definition of skew lines. So two lines that will never intersect and are equidistant from each other. So in other words, they have the exact same distance from each other. So we show parallel lines with just an arrow in the middle, or you could do two arrows in the middle if you'd like. We also have parallel planes. These are basically the same thing, two planes that will never intersect. And while they are equidistant to each other, this one doesn't have the same issue as parallel lines do with the skew because there are no such thing as skew planes. So these are literally just going to be basically on top of each other. And you can, again, mark them with arrows. So we know they're basically just sitting, on top of each other like this. So if you think about like a table and the floor, a table and the ceiling, those would be parallel planes. These are both vocabulary terms, so we do need to highlight them. And then the last two are perpendicular lines. Really, we only need to know the word perpendicular. And we can say that these are lines, could be planes too, that intersect at a right angle. You can also have perpendicular planes as well. But so if we have one line going this way, we have another line going this way, and they intersect at a right angle, then they are considered perpendicular. So that covers all of lesson 2-2, or I'm sorry, yeah, 2-2. I know that there was a lot of vocabulary in there, a lot of writing in there, and I apologize for that. But if there's anything I can help you with, let me know. I would be more than happy to go over some more things with you if you are having trouble understanding. So until next time, guys, see ya.